All right, so we're gonna start by looking at the scenario where we have two people playing skee ball. So we got Mr. Wilcox, Mrs. Gallus, they're playing all day. They're playing so much skee ball. And they collected some data on their performance with how well they did and what they bowled in their skee ball. So we've got two tables here. We've got one for Mr. Wilcox, and we're calling his random variable X. We're calling Mrs. Gallus's random variable Y. So you've got this table for X, this table for Y, both of which have the same values for their random variable. That would be because you can only bowl a 10, 20, 30, 40, or 50 when it comes to skee ball. So underneath are the probabilities that they each calculated for bowling each of those numbers. Okay, so they're definitely different values, two sets of data. Our first three questions are going to be a review from last week, and 4 is just going to be a review from the beginning of the year. And we're going to look at different ways of comparing this data and figuring out who we think is going to win based on those comparisons. So our first question is, are these discrete or continuous? Remember, discrete just means there's gaps. Continuous means there's no gaps. So continuous would be like time, where there's fractions of time, fractions of seconds, fractions of minutes. That's continuous. However, it's impossible to bowl a 34. It's impossible to bowl a 12 because there's no value on this skee ball right here that has those numbers. So we got 10, 20, 30, 40, and 50, okay? Because of that, this is going to be discrete. And it's discrete again because there are gaps, okay? Next thing it's asking is verify that each probability distribution is valid. Distribution just means spread. So the spread of this probability, we need to make sure that it's valid. So remember, for each of them, we have to check two things. We have to check that none of the probabilities are bigger than 1 or smaller than 0. And we have to make sure that they all add to 1. So for Mr. Wilcox, or X, okay, first thing we have to check is that each of the probabilities are between 0 and 1, okay? We've got 0.4, 0.2, 0.2, 0.14, 0.06. He's good to go. The second thing that we have to check for Mr. Wilcox is that they all add to 1. So if we add up all the probabilities, and this little E right here means add, sum of all the probabilities equals 1, let's double check that that is the case. So I'm going to take out my handy dandy calculator over here, and we're going to add up those numbers, those probabilities. So we've got 0.4 plus 0.2 plus 0.2 plus 0.14 plus 0.06, and sure enough, his add to 1, so that's good to go. I'm going to check Y. First thing I need to check is that Mrs. Gallus's probabilities are between 0 and 1, which 0.02, 0.28, 0.55, 0.1, 0.05, all between that range. The second thing I have to check is that they all add to 1 as well. So we need to add the probabilities to 1. And let's double check that that's true. So we've got 0.02 plus 0.28 plus 0.55 plus 0.1 plus 0.05. Sure enough, hers add to 1. So both of these are valid. Okay, so both probabilities are valid. Now we want to calculate the probability that each of these two players bowls a number that's 40 or bigger. So the two biggest numbers that you can get from a single bowl, we want to figure out who's more likely to bowl those big numbers. Okay, so for the probability of X being greater than or equal to 40, we're going to add up the two values right here. So we're going to add 0.14 plus 0.06. When you add this in your calculator, you get 0.2. So he has a 0.2 probability of bowling a 40 or 50, Mr. Wilcox. Now for Mrs. Gallus, we're going to add up her two values. We've got 0.1 and 0.05. When we add those up, we get a 0.15. Now comparing these two probabilities of bowling big numbers, in theory, if you're more likely to bowl a bigger number, you're more likely to win, right? In theory. So 0.2 versus 0.15, 0.2 is going to be bigger. So based on this, Mr. Wilcox will probably win. Okay, because 0.2 is bigger than 0.15. So that's one way that we can look at the data. We can look at the big numbers and we can decide based on the big numbers who's more likely to bowl those big numbers and therefore more likely to win. Another thing we can look at is the average of each of the values. So the 10 through 50 by 10s, what is the average that they can possibly bowl? Now, this is not taking into consideration their accuracy, their aim, their anything like that. Okay, this is just assuming that they're equally as likely to get the same number. So for x, the average of x, okay, how we do that is 10 plus 20 plus 30 plus 40 plus 50, because those are all the possible values that he can bowl. And there's 5 numbers, so we divide by 5. When we add up the top, we get 150, and that's 30. If we do the same thing for y, the y is the same numbers, 10, 20, 30, 40, 50. So that's actually going to be the average for Mrs. Gallus as well, if we assume that they're both equally as likely to get any of those values on any given bowl. Since they're the same, they should tie. However, we know that accuracy and aim and all those things come into play, okay? So we know that this is probably the least accurate. Okay, this is probably the least likely of the 3 methods we're going to go over today. Okay, so everything 1 through 4 has been a review. The first 3, that's everything we went over last time when we started talking about random variables. This right here is just finding the average, which we've talked about since the beginning of the year. Okay, today we're going to keep adding on to this, and we're going to talk about discrete distributions, discrete probability distributions. And we're going to find a visual way to see these things. We're going to give a name based on how it looks, the shape of the probability, okay? And we're going to find the mean based on all of the information in the table, taking into consideration their aim and their accuracy and the probability of bowling each of the values, okay? So in order to do this, we're going to use an applet, which you can find on Schoology in the reference folder. Okay, and the applet that we're going to use is the discrete probability distribution applet. Okay, so what we're going to do is I'm going to quickly shift over to that. Okay, quickly shift over to that, not that, this. Okay, and the first thing that we are going to do is enter the information from the table. So the first thing I'm going to start with is Mr. Wilcox, and Mr. Wilcox's variable was called x. And I'm just going to replicate his table that we saw earlier. So we've got all of the values possible. So 10, 20, we had 30, 40, and 50. 40, 50. And we're going to enter his probabilities of each of these happening. So 0.4 was his probability for 10, 0.2 for 20, 0.2 for 30, 0.14 for 40, and 0.06 for 50. Okay. We're going to begin analysis, and it's going to give us this picture right here. Okay, and I'm going to quickly, while you guys are looking at this, I'm going to jot down what it looks like on my paper. I'm going to draw that histogram, and it's a histogram because it's continuous. All those bars are connected. And I'm just going to draw a rough sketch. I don't really care about the values. I just care about the shape. Okay, and then on our notes, it also says mean and standard deviation. So I'm going to copy those values down as well. Our mean is 22.6, and our standard deviation is 12.777. So if you remember what the standard deviation is, it's really just how spread out our data is. So for Mr. Wilcox specifically, okay, if he bowled in skee ball infinite times, so many times as possible, okay, he should average 22.6 per bowl. Okay, and that's based on how probable it is that he bowls each one. So this one's actually the most accurate of the 3 so far because it takes into consideration his aim, his accuracy, his precision, all those things. Okay, the standard deviation of 12.777 means that on average, most bowls should be within about 13 points of 22.6 on either side. So all the way down to 10, all the way up to 34. Okay, so that just shows how spread most of his bowls should be. It should be within that range. Okay, so this mean is going to come into play because that's his average point per bowl. We're going to quickly shift back to that applet so that we can do the same thing but with Mrs. Gallus's to compare the two. Now I'm going to change the probabilities because she has the same values, okay? So our values are the same. We've got 0.02 for 10. Oops, don't do that. 0.02 for our 10 probability. Oh, wait, okay. Reset everything. Okay. So again, we got 10, 20, 30, 40, 50 as our values because that's all the things she could bowl. Her variable is y. Our probabilities are 0.02. We've got 0.28, so we're getting bigger quickly. 0.55, still even bigger. We've got 0.1 dropping back down, and 0.05 is pretty small probability. So she's not really likely to get those big numbers, but her graph distribution looks different. I'm going to sketch what this looks like as well. Notice that the axis on the bottom changed because we have a different variable name. This one's called y versus the other one that was x. So hers starts off small, it gets big in the middle, and then it drops way back down. Her mean is 28.8, and her standard deviation is smaller, which means the spread of her data is going to be smaller than the spread on average of Mr. Wilcox's data. So moving back over here, I copied down a rough sketch of what these things look like. Okay, notice the shape is drastically different than Mr. Wilcox's. His is bigger on the left, hers is bigger in the middle. However, the mean is really what we care about, because on average, if she bowled forever, her average should be 28.8 per bowl. And the more she does this, hers is going to add 6 more than his for each bowl. So based on this probability distribution, who should win? Well, Mrs. Gallus should win. And in the 3 ways that we've looked at all these, this is probably the most accurate, because it takes into consideration not only that they're equal, not only that he's more likely to bowl high based on these numbers right here, okay, this takes into consideration that she bowls a lot in the middle and he bowls a lot down low, okay? So because of that, we know that Mrs. Gallus should win based on her mean, okay? And a couple of vocab words, and then I'm done with you guys, okay? So the first vocab word has to do with the histograms, okay? So the histograms that we know and love and that we've been working on, okay, for a probability distribution are always the probability on the y-axis, because that's what we're distributing, okay? And whatever the random variable name goes on the y-axis, whatever the random variable is called, okay? It could be x, could be y, could be something else, any variable you want. And from this histogram, we always get a shape that we are able to describe. Okay, so we're able to describe the shape based on the histogram. And this is called skewing, or to skew. Okay, so we can have 3 different representations that can come up. We can have 1, 2, 3. So the first one is the one that looked like Mr. Wilcox's, where it starts off tall and gets small. The second one's going to be the opposite of that, where it starts out small and gets tall. And the last one's going to be like Mrs. Gallus's, where it starts off small, gets big, and then drops back down. Okay, so skewing, just like skewing in real life, I'm assuming that we've probably at least heard that word before. Okay, when it comes to these pictures, it's actually opposite of what you'd think. This one, you'd think it would be skewed left, but it's not going to be. You name the skew based on the tail. Okay, so these 2 are skewed. This one's going to be skewed right, because that's where the tail is. Therefore, this one's going to be skewed left, because that's where the tail is. This one's neither skewed left nor right, okay? So this one's actually called symmetrical. Even though it's not perfectly symmetrical, it's more symmetrical than the other 2. It has a low, high, low, okay? Our third idea is this mean based on the probability distribution, okay? And what the mean means is that for many trials, infinitely many trials as you can possibly imagine, okay, the average, and whatever the variable name is, so in this first example, it was score, is, and whatever the value is. Okay, so for as many trials as you can think of, the mean is going to be what the average score should be, okay, if it's score, depending on what the variable is. And the last thing was the applet use, okay? To access the applet, how we're going to do this is it's going to be on Schoology forever. If we go into Schoology for you guys, there's a whole folder on the main page of Schoology. It's the white folder, it says reference, and you can get it right in there for you guys, okay? Right in here, stats applet, and you'll find it. It's called Discrete random, or discrete random variables. All right, guys, so if you have some questions, just let me know.